Hi, my name is Ayush, and today we're going to be doing the Intro to Java and Object-Oriented Programming. So to start with, we're going to go over the rules of syntax really quickly. So the first thing to note is that unlike other languages, indentations are for convenience and nothing else. So you might be used to having indentations in Python, for example, but in Java, technically all of your code can be in one line. So indentations, new lines, they don't really mean anything in Java. So you might be asking then, how do you define end of line? How do you define what's in the scope of a method? And so for that, we use semicolons and curly braces. So semicolons must be used at the end of every statement. For example, when you declare a variable or initialize it, at the very end, you need a semicolon. And then methods must be open and closed with curly braces, as well as loops and if statements. So as you can see over there, they open and close with curly braces, and all of your following code would go in between those curly braces. Okay, now let's talk about the difference between declaration and initialization. So as you saw earlier, what we did in this slide over here, public int x is equal to 0, was a combination of both declaration and initialization. And so what declaration is saying is basically that there is a variable of some type, uh, and you know nothing else about it. So for example, when we say int x and then semicolon, we're basically saying there is a variable of type integer named x, but we don't know the value. When you initialize and you say x is equal to 7, it is basically using a predefined variable. Again, so declaration, you have to state the type. Initialization, you're taking an existing variable and giving it a new value. And you can do both at the same time, obviously. So now let's talk about comparatives and booleans. So the list of comparatives are over here. There's equal to. The double equal sign basically is when you're comparing two values to be equal to one another. It only works with doubles and integers. Then you have the not equal to. Not is signified with the exclamation mark. Then you have less than or equal to, greater than or equal to, less than and greater than. Um, and yeah, so then you have the if statement itself. So if statements basically work in the way that whatever is inside that if statement's parentheses must be true for the following code to execute. So whatever you input into the parentheses or whatever eventually comes out is going to be a Boolean. And a Boolean is basically a type of variable that has one of two states, true or false. So let's hop onto IntelliJ over here. Not sure if you can see this. Okay, yeah. So we're on IntelliJ right now, and we're just going to get rid of this pre-existing code. And we're going to create an if statement. So if, and we're going to leave it like that. We're going to have an error message show up momentarily, but let's create a Boolean. And we're just going to call it bool. And is equal to false. So we're doing the combination of declaration and initialization together. And we're saying that bool is equal to false. So if bool, then let's say we want to print out, and you're not going to be using system.out.print all that much, but at least in robotics you won't, but for regular Java purposes, it's a good tool to debug. And we're going to say print out false, or true. And else system.out.print false. So the else statement basically works in the way that if this statement ends up being false, whatever this is, if this is false, it will then go to the next line of command, which is then the else statement, and it will print this out. If this was a regular if statement, then it would run through both of these. Like if it means that this would run even if this was true. It would check to see if this was true as well. So we're going to run this. IntelliJ is very similar to what Android Studio looks like. So they have the same UI. So everything that I do on IntelliJ can be done on Android Studio as well. And so as you can see, the system prints out false because obviously this was not true. So let's say we wanted it to print true. Now, obviously, this is not going to be the accurate state, but let's say we put an exclamation mark before the Boolean. So if not bool, and let's print that out. Then we get true. So the exclamation mark, or not, basically inverts whatever would have been true or would have been false. It turns true into false and false into true. So now let's try with actual numbers and comparatives. So let's try int x is equal to 0. Let's get rid of these else if statements for a second. And int y is equal to 1. So if x is greater than y, we're going to print, let's have some, let's say hi. And then else if y is, or just let's put an else statement for now. System.out.println, and then we can say bye. So let's run this, and expected y is obviously, or x is obviously not greater than y, so it would go to the next line of command and print out bye. Now let's say we wanted to have something special happen if x was 0. So if x equals 0, meaning we're comparing x to 0, then let's print out x equals 0. That's the string that we're going to print out. And x equals 0. So notice that it did not print out this else statement, even though it was true. So essentially, this doesn't run because of how if and else if statements work. Now, say this was a regular if statement, right? Say this is a regular if statement, and I had this be if and then the opposite of whatever this is. Then it would run all three of them together. But if, else if, and else work in the way that it would check to see if only one of them is true and run that one. And if none of them are true, it'll default to the else statement. So that's pretty much how the mechanics of that work. So now let's go back to the slides. And so if we read on further, for two or more terms in an if qualifier, use and, the double and sign to represent and the double straight lines to represent or. And so I'll show you guys what they mean in just a second. So let's go to IntelliJ again. And so let's say if x is greater than y and x was equal to 0. And let's get rid of this guy over here. So now, if both of these statements are true, or let's put this as or for now. Let's put this as or. So we'll put this as or, and you'll see it prints out hi now. Even though that this part wasn't true, or statements only require one of them, or one of the qualifiers to be true. So if we had this as and, then if we had this as and, then it will not print out. And we can verify this, that it's not just one of them, by changing y to -1. And now x is indeed greater than y. And since both of these are true, it'll go back to this. Okay, so for loops, let's just open up IntelliJ. And let's just read through what I got here. So let's start with while loops, because I think those are quite useful. So in a while loop, we're basically checking to see whether or not something is equal to something else. So while this statement is true, it's going to keep running no matter what. And so we have an array over here given 0, 1, 2, 3, 4, 5, and 6. And we have a current spot on the array. Now this variable is not really needed, but whatever. And we have a counter variable to basically count our approach going up. And so in the while loop, we say that the current, this variable over here, is equal to array, and then we're going to pull this index from that array. Not that doesn't mean this value out of the array, it means the index. And so the way indexes work are, if I guess I should retype this, I can call this 5. This index over here is still 0. This index is 1, this index is 2. And so what you'll notice is that when I print it out and I ask for the count at the very end, it will say we have 7. It took till the 7th index to find the number 6. Let's say there was no number 6 at all, which is I mean, it's possible. Then we get an error because the while loop basically, or I mean, the while loop would have theoretically run forever, but it just did not find the variable 6 in there. So that is while loops. And now let's go to for loops. In a for loop, you have a few things. You have the declaration of a variable, which we're going to call I. You have the qualifier, we're going to say I less than 10. And you have the counter. So we're going to say I plus plus, which basically means we're incrementing by 1. If you want an increment by 2, you could simply go like plus equals 2 or plus equals 3 to increment by 3. But we're going to increment by 1 for now. So in this for loop, we're going to say system.out.println, and let's just say we print out I. So it's just going to print out 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then obviously, if it were to print out 10, well, 10 is not less than 10. It's equal to 10. So it does not print out 10, and it just stops at 9. So that's the loops for us. Let's go back to the slides. Let's go to arrays. So we briefly touched on arrays earlier, but let's go in depth on this. So an array versus an array list. An array is basically a finite list of a specific object or variable type whose size is determined upon initialization. So what this means is that you can determine size upon initialization, or I mean, you have to basically, if you want to initialize it in a certain way. So we can do this by saying public int and then the square brackets, ARR, that's the name of the array, is equal to new int, square brackets again, and then the size of the array goes here. So from this, we can tell that's an array of 7 integers, all of which are set to a default value. The second way of doing it was the one that we showed earlier, where you use the curly braces as, I guess, as the scope for showing what your indexes in the array are, or what the terms of the array are. The second thing about arrays, which we already covered, is that the first term's index is 0. And then to access an index, you basically give the name of the array, square brackets, and give the index that you want. Array lists work slightly different. So array lists are an object in Java kind of built off of arrays, and they're an infinite list of a specific object whose initial size is determined upon initialization. So this is basically an algorithm, or not an algorithm, but something that it's an object that takes a bunch of arrays and does various things with them to, give you an end result of an infinite sized array. But it's a continuously growing array, I think is a more accurate way of describing it, which is declared as such. So public array list, and you capitalize the A and L, array list, and then you use angle brackets and put whatever type is going to go inside of the array, whether that's integer, double, string, whatever. You put that in there, and then you give the name is equal to new array list angle brackets, same type, and then in the parentheses you can put the size of that array list. So from this data we can tell, or from this line we can tell that the array list of integers is containing 3 terms. Same thing as arrays, the first term's index is 0, and to access an index in array lists we use .get. So list.get and then the index of the term that you want. It's also important to remember that you have to import java.util to .arraylist, or to specifically get arraylist, and .star to get all of the Java utilities. So now let's go into the, I guess, bigger question of what makes Java, I think, not unique, but different. That is what object-oriented programming is. So let's take a look at these 2 pictures. It's of a dog and a cat, and I'm going to ask what makes them different. And the answer seems pretty obvious, which I hope it is, but what makes them different is their properties, physical properties, and their behavior. So dogs have differently shaped paws, they bark differently, Cats don't bark at all. Cats can land on all fours and dogs maybe can't. The differences between behaviors and properties, physical properties, are quantified in a class, which is a framework of an object. So the class has three things: a constructor, its attributes, and its behavior. So let's go to the attributes. Attributes are basically other objects, and they can be given by the basic few that Java gives you, which are int, double, character, boolean, string, or arrays, or you can have your own objects. And then you have behavior, which is basically saying that it is a method of some sort with some kind of return type. Or the behavior is basically the set of methods that your object has with a return type, being either of an object or void. And in the case of void, it basically means that you have no return type. And methods have parameters, which basically is information that you want the user to provide before running the method. So before we get onto reference semantics, let's hop on IntelliJ. And okay, so before we get into reference semantics, let's hop on into IntelliJ and go create a new Java class. Let's delete this one because uh, we're just going to create it again. So create a new Java class. We're going to call it dog. And so obviously the UI has done some stuff before us. Basically, public class dog is all they've given us and the package. So in here, let's start with declaring some instance variables, the attributes basically. So let's call private. Private basically means that the other files in here will not be able to see these variables directly. So private, and let's call it an integer, and let's give it an age. And these are just declarations. You don't have to initialize them here. And let's have the double for its weight. And let's have a string for its name. Obviously not very specific to a dog. Cats can have these kind of attributes too. But let's try and make it a little bit unique with its behavior. So let's say public void bark. And very simply, we will have the system woof. We'll have it bark. And let's say that we wanted it to eat. So here's where we can kind of get a little bit creative. We can increase the weight by 0.1. So the weight increments by 0.1. And so all this is great, but what we are missing right now is a constructor. And so Java gives you one by default, but that constructor is blank. And so let's say we wanted to give some parameters. And actually, before we give parameters in the constructor, let's give some parameters in this. Let's say we wanted to show how heavy the food he was eating was. We can then say int or double increment or double new weight or food weight, and we can add the food weight to our own weight. So system.out.print, we can eat, and then we can create a constructor. So public, and the way we can create a constructor is public, the name of your class, and then parentheses, and then curly braces. And so in the parentheses, we can put our parameters. So let's say int age is one of them, double weight is another one, and string name. So we're basically trying to fill out all of these. Let's say we set weight equal to weight. Now this is gonna run an error in just a second, or not an error, but it's gonna have a gray underline. So as you can see, when you click on the variable, the Java or IntelliJ UI highlights the variables that every time it's used. And as you can see, this guy's not highlighted here. It presumes that it's this, but it's highlighted in gray because it thinks that you mean this, or it thinks that you should mean this, but it knows that you actually mean this. That sounded confusing, so I'm just going to answer what the question I'm trying to pose here. if we want to refer to this variable, or if we have two variables of the same name, Java will basically automatically assign that variable or think that the variable that you mean is the variable that's closest to it. So because weight have the same name here and here, if you just type weight regularly, you're just going to default to whatever's in your parameters or whatever variable is closest in your scope. So to specify that you mean the variables in your instance variables, you have to use the term this. And this.weight basically means you're referring to this guy only. And we can do this for pretty much the rest of them. So name is equal to name. This dot age is equal to age. And yeah, that is that. We can create one more variable just to show a return type. We're going to call it public double or int because that's a return type, and we're going to say get age. And over here, we're just going to return age. So return age basically means that you can use this followed with a semicolon. This is interchangeable for the variable that gets returned over here, and I'll show that in just a second. So let's go back to main. Let's remove the for loop. And let's just make sure that, okay. So let's create a new dog. We're going to call it dog, we're going to call him Frederick. Fred is equal to new dog. His age, he is 1 year old. He weighs 2 pounds. That's probably like, you know what, let's buff him up a bit. 20. That's too heavy. Maybe 10. And let's say, again, his name is Fred. So Fred is our dog. And we want Fred to bark. So Fred dot bark. And so I think I skipped over this. In these parentheses over here, we're basically filling out the needs for our constructor. But yeah, Fred dot bark. And so the dot basically is saying that find all the methods that are associated with the object Fred of type bark. So Fred bark, and if we just run this code over here, we should get a woof in our log. Now let's say we want Fred to eat, and actually there's no way of showing this right now, so we need to find a way to get our age or get our weight. So public double get weight, and we're going to return the weight over here. So let's eat, and let's say the food that we ate was 0.2 pounds. Let's get our weight after that. Let's print this out. So we're going to print out our weight. As you can see, the Fred.getWeight is interchangeable for any variable, and it should give us 10.2 when our original weight was 10. So we ate something, our weight went up. And just to show that the get age works, actually no, it won't work like that, but yeah, that's pretty much all of it for objects. Let's move on to reference semantics. I'm gonna try and okay, there we go. So let's move on to reference semantics. So we were just talking about the default objects which do not have reference semantics, but say you create your own objects, or you use some provided by Java, such as the arrays or array lists. In those cases, what will happen is that you'll have this thing called reference semantics, which is important that you know because it can lead room to a lot of errors if you don't. So say you have a triangle, an object called triangle, and you give it the name red triangle is equal to new and then triangle, and then you give the name of the color that the triangle is. And say Robert is a red triangle. As you say, you create a new triangle named Robert, and you set that equal to red triangle. And then you change Robert's color to blue. Okay? Say you go back and you try and get the color for red triangle. What will this return? Now most of you might say well, it would return red because that's what we kept it initially. But the way reference semantics works makes it so that this would actually return blue because we changed Robert to blue. And I'll show you how this works. So let's open a Paint document right here. So make sure you guys can see it. Okay, perfect. So over here, I have our little red triangle, and I have two variables, red triangle and Robert. As you can see, these are variable names pointing at the same object. So this is how reference semantics kind of works in Java. You have different variable names pointing at an object, and whatever changes are made to that object are applied to every single variable that points at it. So if I were to change the color to blue, now red triangle and Robert are a blue triangle. With that, we are done. So, cool. Thank you guys for watching. I hope you guys learned a thing or two about Java, and I hope it spikes interest to learn more about the language and its various types. Obviously, this is just an introduction. There's um, a lot more that can be learned. So, yeah, thank you for watching.